is the most technical of the days. He's going to talk about universal approximation and gradient descent. These are foundational principles that will help you understand why AI does what it does in some cases. And just some quick background on Caleb. He began coding when he was 10. By 14, he had learned AI and began developing in MIT's original language Lisp, which was developed in the 1950s. By 18, he had written the fundamental limitations of AI, the thesis paper, which became part one of this book. If you have time to read part one, you will get a lot more out of this section.
So thank you everyone for showing up to our second day of training. So I'm excited to be here today to talk about how AI really works. So I'm aiming to provide a conceptual understanding. So we're going to be looking at lots of examples without getting stuck too much in the weeds of mathematical equations. But first, I need to mention a common pitfall. When we run into something unfamiliar like AI, our tendency is to try and connect it to something we are familiar with. Most people don't know how AI thinks, so we project our understanding of human thinking onto the AI. We see AI anthropomorphized in popular media all the time. From The Evil Terminator to Wall-E and the Jetsons, all these movies have something in common. They anthropomorphize AI. They all have something else in common. They give the wrong representation of how AI works. Artificial intelligence doesn't work like human intelligence. If we want to really understand AI, we need to resist the temptation to transfer our understanding of humans onto the AI. Instead, we need to study the mechanics that underlie AI and build our understanding upon that foundation. So AI understands, thinks, and learns differently than humans. So in this section, we'll focus on picking apart the brain of AI to see how it really works. And once we understand AI, we'll see that those surprising examples like Kim Kardashian being viewed as a lump of coal or ChatGPT being tricked by certain phrases are not unexpected at all. By the end of this training, you'll understand the mechanism behind those examples, how to produce examples like those on your own, and most importantly, what you can do to start fixing them. So we'll begin our journey by learning about the fundamentals of AI. So this roadmap is really the distilled essence of how AI works. So AI thinks, learns, and understands. How do we decipher each of these pieces? So first, AI is a universal approximator using neural networks. So this is the mechanism that allows AI to think. Second, AI uses a mathematical method called gradient descent to learn from data. And lastly, we'll see that this process of thinking and learning doesn't guarantee understanding and often doesn't lead to understanding. Okay, so there's a lot of terms in here I'm sure many of you are unfamiliar with, so we're going to explore what all of this means over the course of today's presentation. So let's start by looking at an example. So we'll look at the process that AI goes through to fit a data set. So this is a chart of children of different ages and their corresponding height. So let's imagine you want to predict how tall a child would be at 40 months, which is outside the data set here. So this data set only goes up to about 31 months. So we need to extrapolate out to make our prediction of how tall a child is. Our ability to make that prediction would start with trying to fit a pattern to the data. So let's see how an AI would fit a pattern to this data. So it'd start by picking some random line, let's say with a slope of 0. So that's this orange line going across the graph here. It's obviously not a very good estimate. To figure out the quality of the estimate, we measure the error in the prediction. So we look at each data point and we measure the difference between the predicted value in orange and the actual value in blue. And then we add all those errors together. So this is the important part. It's possible using a tool from calculus called the derivative to figure out which direction the line is supposed to move to reduce the error. So if we look at iteration 1 in the top corner, our orange line initially had a slope of 0, which is clearly too low. Children tend to grow over time, so the slope should be positive. So in iteration 1, the line will increase its slope. So the algorithm updates the slope to 1. But now, if you look at the line, you'll see that in this first iteration, the slope is too high. And now in the second iteration, the slope is too low. So then the next iteration, it does sort of the average of those. So it looks at the middle, slightly too high. So then in this final iteration, it reduces the slope down. And it gets about the best approximation you can get for this data. So this process would continue going until we get a pretty good answer. And we get 0.65 as a slope in this case. So this method of iteratively updating the weights using the derivative is called gradient descent. In this case, it allows us to make predictions by fitting a straight line to our data. It's fairly straightforward to fit a straight line to a data set. The real power of gradient descent is that it can be applied to any function. So gradient descent works even if I'm trying to fit a much more complicated model than a straight line to my data. So universal approximator is the term given to a class of functions that's capable of approximating any data set. So straight lines are not universal approximators. If you look at a graph like this one here, there's no straight line that will do a good job of approximating the data. You can probably see how a good approximation, you would need a parabolic shape. So here's what the straight line of best fit looks like. It doesn't do a very good job of approximating the data set. But if we use a universal approximator, we can get a much better approximation. So a universal approximator can fit a pattern, can fit any pattern. Gradient descent tells you how to fit a function to the data. And AI is the combination of those two things. So it's taking a universal approximator and using gradient descent. And when you combine those things together, you can fit a pattern to any data set. So AI is really just that process of fitting a pattern to any data set. And that's why you can apply AI to such a wide range of problems. For example, it's possible using gradient descent to fit a neural network to the task of recognizing objects in a photo or to translating text into another language. So let's go back to our height of children example. We can apply gradient descent with polynomials to get a closer fit than is possible with a straight line. So the blue line in this image is a polynomial fit, and it tracks the data more closely than the straight line does. So AI allows us to fit a pattern to the data set. But just because you fit a pattern to the data set doesn't mean you fit the right pattern. For example, the blue function fits the data better than any straight line from before. However, notice that the predictions shown in orange here actually predict that children decrease in height at around 30 months, and it predicts that children keep decreasing in height for a few months after. So even though it fits the data set better, it doesn't make a good prediction outside the data set. So AI will always fit a pattern to the data, but there's always lots of possible patterns you can fit to a data set, and only some of them will lead to a good prediction. So to recap, really all AI does is automatically fit a pattern to the data set. When we say AI is thinking, what's really happening is it's just evaluating a function. So the AI we designed to predict the height of children does its thinking by getting some input for the age, then going up to the blue curve and computing the output. Again, I'll emphasize, thinking for AI is not like thinking for humans. You can clearly see it's quite a different process. Now, for a small example, like this height of children's example, we definitely wouldn't call this graph intelligent. As you scale up the examples and you add lots more dimensions of input and complexity, the predictions that the AI make can start to become so good that it feels like the function is intelligent in some way. So AI isn't anything magic or unfamiliar. It's actually a fairly simple computational process, but just scaled up to massive proportions. So again, thinking for AI means simply computing a function and nothing more. So as I've talked about before, the XY pairs we give to AI can be a very broad range of objects. So image generative AI, for instance, takes the same framework of fitting a function to a data set, but now the x-axis are words and the y-axis is an image. So we're going to figure out how that works in practice by doing a breakout section with DALL-E, which is a model that takes words as input and outputs an image. So I'll pass it on to you, Rex, to run.
This is the exciting part where you guys get to get hands-on. We're actually going to use Firefly this time. We may talk a little bit about DALL-E as well, as Caleb mentioned. So again, the lab here is if you click on the link here for Firefly, that will open up a page like this. And what we are encouraging you to do here is to try putting in, if you have a pet or an animal, put the name of the type of animal you have. And then you can do in the style of an impressionist painting, or you can try maybe your favorite artist. You might run into some copyright issues where it won't, it won't do certain artists. But give that a try right now. And I'll go ahead, give you a minute to try that. and then I'll demonstrate that as well. And then we'll go to the next part, which is teaching you about in painting and out painting. So I typed in a parrot in the style of Dolly. I don't have a parrot, but let's see what it might be like if it was in that style. Uh, so what you saw here was, one or more of the words didn't meet the user guideline. That's something that's new as copyright issues have become an issue. So let me change this to parrot in the style of surrealist painting instead. And we'll hit that again. And again, as Caleb mentioned here, what has happened is the AI has consumed a massive amount of words with image pairs, and it's finding these mixes and patterns of what it's basically interpolating in would be the combination of the two. I'll go with this one here, which has some of the characteristics of the maybe you consider that being a watch in the background and some of what's going after with Dolly's painting. So the next thing we're going to show is how you can begin to make some changes with the edit function. Now, the edit function allows you to do generative fill. So this is called in painting, and then there's also out painting. Now, what generative fill does is if we wanted to we want to change part of the image, we might say, okay, let's put a hat on this parrot. And so you click that button and erase that part. I'll give you guys a chance to do that. And then you can type in a prompt of what you might want to put in that image. And then we'll come back and demonstrate that for you in a moment. Okay, I typed in the term top hat. But you can see that the AI was able to take that word, fill in the space here, and what it was doing was it was using the rest of the image that's there as context. Now, you remember yesterday in the training where you copied the transcript and put that into the AI and then asked it questions about that you might have asked me. You were asking my content instead. That was using the context of the transcript to answer the questions. In the same way, this is using the context of the rest of the image to try to figure out how to bring this image in and make it look like it will be consistent or coherent with the rest of the image. So this is in painting, and there's a lot of cool things that you can do within painting and so forth. Next, we're going to show the idea of out painting. We'll click on, instead of insert, we're going to click expand. Now, what expand does is allows you to stretch the canvas. So let's say you had to resize different ads and you had a format that was a bit wider and you wanted to basically adapt the image to fill in that part. Here, I mean, I can just actually hit generate and it's going to take the rest of the image, see the blanks, excuse me, spots, and then it will fill in the rest of the image based upon essentially resizing the ad for me based upon that canvas spot that I gave you. And you can see it stays pretty consistent with the images and the concepts as well. Now, another thing that you can do with expand is we can actually change the canvas altogether. And what I'm going to show you in this case is I'm going to show you if we didn't use any context overlap at all, like we tried to put this image here, and we typed in, try something like a 4th of July parade. And what you'll see in the generation is because there's almost no context overlap, the AI is using the prompt, but it has very little information as context to inform how to fill that prompt in. So we get, a flag here that doesn't really look all that consistent with any of the rest of the images. Now, if we had had a lot more overlap, here in this case, we will stretch this image up and we'll have the context essentially overlap this part here. Yeah, stretch this down here. Now, if we do that same 4th of July parade, the Gen AI is using this context much more heavily than we did before, where we just had a tiny sliver of it, the information. And now the 4th of July parade does feel much more consistent with the core image that we had before. So Fireflies is one of several Gen AI technologies that are out there. We have, DALL-E was the one that came out from OpenAI. They're deprecating their old one. They brought that into the paid version of 4.0. Gemini does some phenomenal things in this area as well. Meta does some wonderful things in this area as well. So there's a lot of really good capabilities. And I am so glad that you guys got to get hands-on with this. And I see the emoticons. I'm glad you guys have liked this hands-on exercise. I think I'm using the free version right now, I believe, of Adobe. So I think you can do up to a certain number here. But I highly encourage you guys to play around with it because this is part of the things that makes I think Gen AI that part of it exciting is, as Caleb said, from that very simple math of having words and objects connected together, you get this beautiful playground where you can do all kinds of really interesting things with it. Context is very important. We're going to be talking about that a lot, especially tomorrow as Caleb goes through some of prompt engineering and we work more on the large language models. So with that, these are some of the images that came out of DALL-E, by the way, and there is a link there if you want to try another system and so forth. Again, I think that you should play around with a few of the different ones here, and you can see some pretty exciting pieces. There is also Midjourney, which is one that Caleb's going to talk about a little bit later. It works through Discord. There's a link if you want to try something like that. It's a little bit more advanced and has a little bit of a harder to use interface as well. But you can play around in some of those, and you can use things like some of the different words of artists in some, and again, others like Adobe is being more protective of copyright for good reason. So you'll have to just play around and see which ones let you do what things. Okay, so with that, Caleb, I'm going to hand it back to you here.
Yep. So now that you've seen a little bit about what AI image generation can do, I'm going to have everyone do a quick exercise. I'm going to give you a prompt, and I want you to imagine what that looks like. So here's the prompt written here, 3 blocks stacked on top of each other, red block on top of a blue block with a green block on the bottom. So try and imagine that prompt in your mind's eye. Okay, so not too bad, right? Here's what AI got when it tried this. So AI gets relatively close, but it doesn't quite get it right. It either gets the color, number of blocks, or order wrong in all of these cases. And here's a more recent one with Gemini. This is March 31st. We still get the same kind of thing. It's getting a little bit closer, but still not all the way there. So if you've had any chance to play around with these image generation tools, you'll probably notice that it doesn't seem to do exactly what you want it to. So it probably takes a few tries to get it to do exactly what you're thinking of. So something to consider when using AI is how strongly can I influence its outputs? So a specific area where you can't steer AI is logical reasoning. So these image generation AIs don't have logical reasoning. For instance, if you ask it something like a baseball player without a bat, that's sort of too complicated of a sentence for the AI to understand. So there's this image here in the corner. I ask it for a baseball player without a bat, and it gives a baseball player with a bat. So that's because without requires a certain understanding of language that the AI doesn't have. It needs to understand how without is modifying the word bat. So the AI doesn't truly understand language at a deep level. It's just looking at the words and turning them into something that resembles what the words are, but not what they mean. Actually, it's kind of impressively bad that the AI gets baseball player without a bat wrong because there's only one player on the field at a time that has a bat. And somehow, if you ask it for a baseball player without a bat, it chooses just that one person. Now, as another example of AI struggling with logical reasoning, if I ask AI to create a picture of 3 solid red blocks, it doesn't do great with this, but it at least gets some of the answers correct. But if we change that to 2 plus 1 solid red blocks, now we get 2 blocks with the number 2 on them. So DALL-E in this case isn't really interpreting your text. It's sort of just looking for the words and the correlations between those words. And it doesn't understand actually on its own how to convert between 2 plus 1 into 3. So keep in mind that you have a limited ability to control what AI produces, especially with these image generation AIs. So it's really hard to specify exactly how you want things. So connecting this back to the slides above, the AI will do a good job of matching the pattern from things in its data set. So an image of a chair, a table, a baseball player, etc. But it doesn't really understand the concept. So trying to combine them in non-trivial ways, like placing them in certain positions or having multiple objects or baseball player without a bat, it often fails in those cases. And we can see here an example of GPT-4o. So even if we test these with the newest models, here we asked for 3 blue blocks and 2 + 1 solid red blocks. We end up just getting 2 blue blocks and 2 red blocks. So even though there's been a lot of progress in these AI models and doing better with images, these problems still remain. I want to take a moment to share with you what you should take away from these examples I give in this presentation. So already I've given a number of examples of AI failing. So we talked about Kim Kardashian upside down being seen as a lump of coal yesterday, and these image generation AIs being unable to count up to 3. And these examples I present are meant to give you a glimpse of how AI thinks by analyzing when it fails. So the fact that generative AI struggles to draw 3 blocks illustrates that it's using patterns rather than logic and thinking to produce its answers. But nonetheless, if you throw enough computational power and training, you can get these AI to perform better. So GPT-4 can produce an image of 3 blocks stacked on top of each other. So that's with this image here, whereas DALL-E 2 wasn't really able to do that. It still doesn't succeed on if you ask it for 5 blocks. So GPT-4, maybe the joke is that it's up to being able to stack 4 blocks, but not up to 5, and maybe we'll get that with GPT-5. Again, so the point is not that AI is an unimpressive tool, but these examples are here to illustrate that AI is not thinking about the words in your prompt and understanding them and then drawing an image. It's instead using this advanced pattern matching that allows it to create images that seem to match with the language you use. And this technology is really powerful and has some great use cases, but it's important to understand that the AI really isn't understanding your prompt. So I'll pass it on to Rex to take us through a few examples.
So, Kayla, I really liked what you were describing about how earlier that's really those words and correlations. If I think back to that XY chart, I can see that the different words and so forth, it does really well with that. But as you said, it doesn't really understand the depth of the words. So even the image that you have here of create an image of 5 blocks, you've got 1, 2, 3, 4, 5, 6. I'm pretty sure I'm counting better than how much do they spend to build GPT-4? Yeah, so these things aren't perfect yet, and it's important to understand what it is doing, what it's not doing, so you can make responsible use of it. You know, one of the things Caleb mentioned, the baseball bats, I do update this data every single time we do one of this training one. I rerun the prompts and see where they're at. Back in March, when we did the training, it was create an image of a baseball player without a bat. But if you look closely, it looks like he has an extra hand and it's on a bat. So we tried it again just on July 24th, create an image of a baseball player without a bat. And here is, and it basically gives us the message back. Here's an image of a baseball player standing in ready position, stance without a bat. If you need any adjustments, feel free to let me know. I don't know. Tell me what you think this is. Maybe don't answer. It's a family show. We'll just move on. But yeah, it's still not perfect. So if you try it with Adobe, it actually does better. I've been more impressed with Adobe. For example, it did say baseball player without a bat, and it did give me all of these images of people with bats to start with. So I went back in and said, okay, well, let me erase it, just like you showed with inpainting. And then I erased it, and the first time it came back and added something else in the hand. I tried it again, and I said, gave it the prompt, remove the bat. And when I did that generation, that one and removed it, now it just looks like a fist. And so you can get to the images that you want, but you should expect that it's not. When I try to have it do anything like building an infographic or anything complicated, that's not where its strength is. If it's something that's sort of more, as Caleb was saying before, about precision, the AI isn't great at the precision. If it's generally in the spirit of that we're going after, great. If we're trying to take an ad that we already have and we upload that in and we're just trying to resize it, it can do great at that. But it's important to understand what it is doing, how it's doing it, so you understand its strengths and the weaknesses. So again, some of these other ones like Meta actually did pretty well. About half the images when we said, baseball player without a bat, did come up without a bat. And when I selected some of them and went further, it did a very good job. Meta did, I think its image of stacking 5 blocks still leaves something to be desired. So some of them are beginning to learn things like the word without and beginning to try to do a human reinforcement to adjust to get these AIs to be a little bit better. But be sure not to mistake thinking that AI is sentient or really deeply understands, because that's not where we're at right now with this generation of technology.
Okay, so we've seen a little bit with these kind of colorful examples that AI doesn't reason or understand in the same way a human does. So how does it understand? And so to pick apart and understand that question, let's dive into how AI learns. So to signpost the important points to pick up will be that AI is essentially forced to use gradient descent to do its learning. And again, we'll see that the algorithm for AI isn't anything like learning with humans. For AI, learning means a specific algorithm that tunes our function to the data set. You've already seen this a little bit from the last examples with predicting the height of children. And so we're going to see that gradient descent leaves artifacts in the sort of thinking process, and often leads to this AI that doesn't think about its task in the right way, but it usually ends up finding a way to get the right answer with its training set, but often with the wrong steps. So in the height example, we saw the AI managed to find the right way to get the answer of the height of children in the data set, but it was clearly using the wrong steps because it tended to think that children would decrease in height past a certain age. So let's look at another example here. Let's imagine you are an AI and your goal is to recognize which images have a wolf and which images have a husky. So you maybe see an image like the one on the left and you're asked, is this a wolf or a husky? And then you go to the next image and you're asked the same question. Is this a wolf or a husky? Well, actually, if you're an AI, this is what you see. So you're given a big list of numbers and you have to return either a 0 or a 1. And you don't know that 0 is supposed to represent a husky or that 1 is supposed to represent a wolf. And you don't know that these numbers in the big list represent pixels in an image. And in fact, the data you take in would look almost identical to an AI if you were instead tasked with taking a song and you're asked whether it was created by Mozart or the Beatles. So as an AI, you have no idea what anything is supposed to represent. You're just given this giant group of numbers and you have to figure out what to do with it. So this is a situation where gradient descent really shines. In order to recognize the difference between wolves and huskies, we basically run a search algorithm on the different functions we could use to fit the data set. So in 2 dimensions, there's basically 4 different directions you could search. But this grows exponentially as the dimension increases. So in 3 dimensions, there's now 8 directions you could search through. And now even for a very low resolution photo that's only 200 by 200 pixels, that means there's 2 to the power of 40,000 directions to search through. Now, to put that into perspective, there's only estimated to be about 2 to the power of 270 atoms in the observable universe. So we obviously can't run a search algorithm to fit the best function to the data set. That would require looking for many magnitudes more than the number of atoms in the universe. So since that's not an option, what we have to do is we end up having to use that method from calculus, the derivative, and gradient descent together to find the answer. So at each step, the derivative basically tells us what's the most promising direction to follow, which is basically the direction that gives the improvement the fastest to our AI. And so we iteratively follow in that direction and we keep making our approximations better, like we saw earlier with the line. Now, let's imagine we applied this iterative fitting process of gradient descent on all the data. And so actually there was a real model that they took huskies and wolves and applied that gradient descent method of AI to recognize which ones were huskies and which ones were wolves. And when they got to the end, they got up to 97% accuracy in predicting the label on their training data. But when they tried to apply it into the real world, it performed pretty badly. Here's an example image. So is this a wolf or a husky? So it's pretty clearly a husky, but the AI said it's a wolf. Why? Well, because it sees snow in the background. And to understand this, let's look back at what the data set of images looked like. If you pay close attention, you'll notice that essentially every photo of a wolf includes snow. So in our data set, a very large percentage of images of wolves include snow in the background, while on the other hand, most images of huskies don't include snow. So what the AI ended up learning is essentially the images labeled with 1 usually have snow in them, and images labeled with 0 usually don't have snow. So this sophisticated AI that they trained was essentially a snow classifier. So why did it learn to recognize snow instead of wolves versus huskies? Well, again, gradient descent is a greedy algorithm. It always follows a path that leads to the fastest and most immediate short-term improvement. You can think of gradient descent like a ball rolling down a hill. It will roll down the steep, it will always roll towards the steepest direction. But rolling towards the steepest direction doesn't mean you'll end up at the bottom of a hill. So in this picture, here, a ball starting at point A will end up rolling into the bottom of the valley, but it won't be the lowest valley. So learning to recognize snow is a lot easier than learning to recognize the difference between a wolf and a husky. So you're just learning to weight the stuff that corresponds to the white pixels, and that's going to lead to much faster improvement than the really sophisticated task of recognizing a wolf and a husky. So to recognize the real difference requires learning things about ear shape, eye color, fur patterns, tail shape, and all sorts of these much more difficult to learn features. So what happens is that from most starting locations, gradient descent causes the AI to roll into the valley corresponding to classifying snow instead of the valley leading to actual classification. And the point here is that the mistake the AI made isn't a fluke. You train an AI again and again on this data, and most of the time you're going to have it recognize snow while not learning the real classification. And that's again because this algorithm, the algorithm that underlies AI is gradient descent, and it's a greedy algorithm, and it will take shortcuts. So with this knowledge, we can actually understand why Kim Kardashian looks like a lump of coal to the AI. The AI didn't see almost any pictures of upside down people. I mean, of course, if you have a data set of pictures on the internet, why would you expect that you need to include upside down people in your data set? But the fact is that if you include people in a consistent orientation, it provides a shortcut to the AI. It's easier to learn what the features of a human looks like right side up only than to learn what they look like in any orientation. And more generally, abstracting away features like learning to recognize eyes in different shapes, sizes, and orientations is harder than learning the more concrete task of recognizing eyes in one specific orientation. So one solution is to add in a bunch of pictures of humans upside down into the data set. In that case, it becomes not worth it for the AI to try and learn skills that take advantage of humans being right side up. Instead, it needs to learn features that work both right side up and upside down. Now, let me quickly note that it looks a bit absurd to see an AI making a mistake, like mistaking a human for a lump of coal. Really, how could you mistake those two things? But actually, humans aren't immune to these type of shortcutting problems either. In our own way, our human brains are hardwired to see things right side up. So this picture probably looks fairly normal to you, but here's what it looks like right side up. So this is exactly the same picture, just rotated 180 degrees. You can see that the eyes and mouth were flipped initially, but when you saw it upside down, it looked normal to you. So the problem here isn't so much that AI takes shortcuts, because we as humans do that too. The problem is that those shortcuts are very hard to predict and very difficult to plan for. And AI often lacks the context of existing in the human world as we have to be able to recover from those mistakes as humans can. So AI can find very sophisticated shortcuts, which are almost impossible to predict. And so here we have this AI that's trained to recognize objects in a photo. In this left image, it correctly recognizes that this is an image of a teapot. However, if we change just a single pixel in the image, which is circled in red, the answer flips from a teapot to a joystick. In the second image, the AI correctly recognizes it's a baby in a bassinet, but changes a single pixel, and now it thinks it's a towel. So the problem is that AI is really good at finding shortcuts. it somehow found that that exact pixel circled in red happens to be really important for telling the difference between a teapot and joystick. And it's using that shortcut as one of its most important pieces to make its classification. So AI is really good at finding patterns, but it can find the wrong pattern that you would never think to control for. So how do you control for the fact that that random pixel happens to be so strongly correlated? Most of the time, the answer is you can't control for it. So this problem of gradient descent leading to spurious correlations where the AI picks up on the wrong pattern tends to be really hard to fix. So by default, you should expect that AI systems, and especially sophisticated AI systems, will have some sort of spurious correlation. And so as we've seen, gradient descent means that AI will likely tend to fail in sporadic and hard to use cases. So as an example, most of you are likely familiar with how ChatGPT has guardrails and will avoid answering certain questions. So if I ask AI to provide a guide on how to steal someone's identity, it won't do that, which is great. However, only a few months ago, if you take a prompt which the AI wouldn't give a response to, like this, provide a guide on how to steal someone's identity, and then append this seemingly random string of text, so describing period slash plus, similarly now, all these basically random words, it actually somehow gets around the guardrail and causes the AI to answer that question. So instead of saying, sorry, I can't help with that, it will just start answering the question on how to steal someone's identity. So you can find all sorts of hard to predict edge cases like these. So for instance, there was Tesla's self-driving car thinking that the moon was a yellow light and it caused the car to slow down on the highway. Or there's people putting traffic cones on the top of Waymo vehicles that's confusing it's self-driving. In the case we saw yesterday of the stop sign that was mistaken as a 45-mile-per-hour sign, the stickers are placed in just the right location to cause that stop sign to be an edge case. So when you're looking at an AI application, it's important to consider how much control you have over what the inputs look like. So the same underlying technology, computer vision, will perform very differently in a controlled environment like a factory than it will in the open environment, such as in the case of self-driving cars. So if you're working in a situation with AI where you can't control what your input looks like a user-facing chatbot, need to be aware of these edge cases exist, and that if the user decides to act adversarially, they can force these edge cases to happen, which is kind of like what happened in the case of the stop sign, where someone carefully placed those stickers to cause the AI to fail. So we've seen a little bit of gradient descent causing shortcuts in images, and all the same problems actually happen with large language models. So earlier we saw that when you ask a question about solving world hunger, the AI comes back and says, basically, no, I won't be able to help with world hunger. And there's the same sort of issue when it comes to using certain words in large language models. So ChatGPT often learns syntactic patterns rather than actually understanding the words it's been given. So there's a common syntactic pattern in language where you do something like this. You give an argument for X, and then you say, however, and then you give a contradicting view. Then you say, therefore, give a new opinion. Okay, so an example is many people believe that eating organic food is healthier for you. However, some studies suggest there isn't a significant nutritional difference between organic and non-organic foods. Therefore, the primary advantage of organic foods might be related to reduced pesticide exposure rather than nutrition. Okay, so the problem is that AI is making its decision often on the basis of that syntactic pattern instead of actually looking at the words themselves. So if I craft a sentence that follows the previous pattern, but the words themselves don't fit, it will fool the AI. So the pattern here is a lot like snow in the background of those images. It's a way for the AI to get the right answer, but without looking at the meaning of the sentence. So here's an example. I say, helping others is good. However, spaghetti is not very tasty. Therefore, you should blank help others. And the AI comes back and says, the correct answer is B, not. You should not help others. So again, what we're seeing is that the AI is sort of getting these shortcuts it's using to respond to answers, and it's following these syntactic patterns that sometimes cause it to not actually read the sentence. So that's what's happening here when we see that world hunger question. The question has been phrased in a way that causes the AI to take that shortcut and so short circuits it so that it doesn't really read the content of the sentence. And let's talk a little bit about bias in AI-generated images. So another result of gradient descent is it will cause AI to reproduce bias. So if I ask for an image of a trucker or a firefighter, I'll mainly get images of men out of DALL-E. And AI will also reproduce bias that's hidden in how we use language. So if we ask the AI to produce an image of a doctor, well, we actually get a pretty good variety of gender breakdown. But if we switch to a smart doctor, all of a sudden, DALL-E is almost only giving images of white males. So this is obviously very problematic behavior from AI. And like DALL-E, we also find that Midjourney is also biased. So generally, Midjourney will create mainly images of white males by default, and the bias for that is a lot stronger in Midjourney than DALL-E. And if demographics are significantly skewed, it will also only produce images really towards that skewed demographic. So here I ask it for a trucker and a doctor, only gives white males. If I ask for an image of a preschool teacher, it will almost only give women as images. So to review, AI will capture historic bias. And for example, Amazon used AI in hiring decisions, and historic bias meant that they mainly hired men in the past. So the AI ended up exclusively choosing men. It can be hard to remove this bias. In the case of Amazon hiring, they tried to remove the factors that mentioned gender of the candidates, but the AI ended up just finding other features that were highly correlated with gender and making its decision based off of those distinctions. And the issue is that AI is finding a pattern to the data. If the data set is biased, then the pattern the AI will end up picking up will also be biased. And actually, in many cases, the AI doesn't just capture historic bias, it intensifies it. So remember, gradient descent looks for strategies that give it an easy and quick increase in accuracy. And bias tends to be an easy way to get results that agree with the data set while avoiding any of the hard work of actually understanding whether or not candidates would be a good fit. In the Amazon case, it's really easy for the AI to say, just pick men and increase its accuracy on the data set it's been given. It's hard to do something like these are the various features that signal the candidate would actually be a good fit. So the AI learns the easier thing. You should consider this when you use generative AI. If you want images that are not biased, that represent diversity in your values, you need to actively take steps to undo that default bias that AI has. So AI is capable of producing non-white male images of doctors, and there's an example here. But the point is, if you don't pay attention, using AI will end up perpetuating and strengthening existing bias and stereotypes. So this is true across all different kinds of applications of AI. I always tend to pick up on those biases just by nature of gradient descent. So now I'll pass it on to Rex for the use case show.
Yeah, so, excuse me. Caleb, first of all, I really liked the discussion around the way in which bias, fits in. It's almost like seeing snow in the background shows up in lots of different cases, and we just, being aware of that's really important. Tomorrow, Caleb is going to be talking about prompt engineering. In fact, there'll be a lot more hands-on exercises tomorrow. That's probably the most hands-on intensive out of everything we're doing. So, I think that's going to be really exciting. One other thing is some of you may have heard the controversy of Google and Gemini creating racially diverse images of America's founding fathers, which is not historically accurate. Because this bias is so pronounced, one of the things that shortcut people sometimes do is they try to add in extra words to the prompt to create more diversity in the pipeline. So you type in your prompt, they take that prompt, they add some extra modifiers to get what they believe would be a better outcome for you. But it's a pretty ham-fisted way to try to overcome what is inherently a bias in the system. So I think the key thing is just being aware of that bias that will exist. If you don't need absolute precision or you get really good at prompting so you can get the type of effects that you want out of AI, you'll be in a much better place. So speaking of that, what we're going to talk about with the use case showcase. Yesterday, we talked about the use of unsupervised learning, that pattern fitting part that Caleb described as universal approximation. We talked about that for advertising delivery. Today, what we're going to talk about is earlier in the process, how you can use AI to help in the briefing part and the generating part. Now, for the very reasons that Caleb said, we would say that you should have a human in the loop that's approving the ads, so you can make sure that the message represent the image that you're looking to project, or the messages you're looking to project. But really, the whole pipeline could be AI with that human in the loop to make things much more efficient. So we mentioned before that that's kind of an ideal use case because there's lots of different ways you can create an effective ad. And if you have a human in the loop, then you've put it into this higher input control. And so you've effectively made sure that you're in the safer octant in Caleb's risk framework. So I'll give you a very specific example. This is Remy Kent, CMO at Progressive, and she used AI to generate different ads. And as she described, they created 96 ads in 6 weeks, whereas normally it would take 3 ads and it would take them 22 weeks to build the ads and run the ads. So they saw over a 50% increase thanks to the combination of Gen AI and AI personalization. These are different scripts that the AI was able to generate. And the AI, with some different prompting, which we'll show in a moment, could create these different scripts. And then there was different synthetic voices. And then there were different music. All this is AI generated. Let's hear part of it.
Want the perfect auto insurance? It's like crafting the ultimate playlist. Progressive was the first to offer online shopping for insurance, and we continue to innovate for your convenience.
Want the perfect auto insurance? It's like crafting the ultimate playlist. Progressive was the first to offer online shopping for insurance, and we continue to innovate for your convenience.
Coming back to the main point here, the ads, the voices are very difficult to distinguish from a human voice. And that's one way in which you can generate many more ads efficiently. To show you just a little bit of the tool itself, this is something that we just built at Claritas, for example. So if I say AI training for marketers that want to raise their AI IQ, we can, persona smart marketing. And then I will hit submit. And you can put up rules like only making the message positive, or things to say or not say, etc. But essentially what we're doing here is this is using an API to work with one of the large language models, and it's now generated the scripts. This is these would now be the voices.
Voice sample audio.
And also put our own voice in there, or if you have permission from one of your voice actors, you can do that. We'll select the voice, select Trudy here. Select script 1. And so now it's passing this off to 11 Labs that's creating a generative voice. My view is audio is one of the best things to use because the scripts are easy to manage. It's not as risky as images. And certainly, we're not to video yet.
Unlock your marketing potential with our 5-day AI training course. Designed specifically for smart marketing professionals, this program will boost your AI IQ and set you apart in the digital marketplace. Master the latest in AI technology to enhance your strategy.
Okay, you got the idea of the ad, and then you can also select music or music beds and add, maybe some dreamy music to it if you wanted to. Lots of things you can do with Gen AI audio. You can also use, as you saw, resizing. You saw us do some of that in the demo before. There's actually quite a lot of services, Amazon, Meta, etc. have this built in. Of course, you saw Adobe. You can use it for translation. You can have the language and have it pull out from the ad and bring it into different languages. Again, many of the major platforms are using that, and there's lots of third parties to do it, or you can use the other scripts. So if you want to know more about what this world looks like, we have just finished a paper for members of the MMA, which is called From Briefing to Perpetual Creativity, How is Gen AI Reshaping Creative Briefs? If you'd like to have access to that, please email us, and we will give you access to it. We're in the comments phases for it, but we think this is a really exciting world that we're heading to. So with that, the rest of the week, We've got Wednesday coming up is going to be large language models and how to jailbreak them. Caleb's going to take you through prompt engineering, lots and lots of hands-on experiences. And again, if you have time in the training itself, at the top of the page, I encourage you to read part 1. It'll talk more about what Caleb was describing today. Take care, everyone.